determining equations of sinusoidal graphs. So as I said, that's more often what you're going to be asked. Given the graph, what's the equation? Now, in this first one, though, it's a review of what we were just doing. Okay, so we graphed y equals cos theta with you. The ones that we just did were sines. So remember the difference, the same shape, but now your y-intercept is at 1, not 0. Okay, so it starts at a max. If you think about going to the right, it's starting at a maximum point. We're going to do use our transformation skills to sketch the graph of this. Okay, so think about what's happened here. You don't have to write it out, but think. There's a vertical stretch by 3, horizontal stretch by 1/2, left in the x-axis, right pi over 6, up 1. So based on what we talked about before, plot your midline first. So at y equals 1. Okay. Then think about this point here on my original. The horizontal stretch won't affect it, but the vertical stretch will, right? So it's a vertical stretch by 3. So first of all, maybe you want to think about just where your maxes and mins will be. So 1 plus the amplitude is 4. So kind of in pencil, you can kind of just put dotted line or whatever. And then 1 minus 3 is -2. Okay, so that midline should be halfway in between, right? So now you're not going to graph any points above that or below that. Here, now with that -3, okay, this, if I do that stretch on that point in particular, I would get -1 times -3 is -3, and then up 1. So I would get this point, again, in pencil. I'm not doing anything in pen yet. Okay? Because normally the max, but that reflection means that's a min. Okay? Horizontally, that point doesn't get stretched, but I've got to go to the right pi over 6. So my min now is, the closest one is at pi over 6. So you want to take a look at your grid markings. Again, they're divided into 6, which is pretty common. Okay, so that it's now going to go up from there. So I just put a little arrow to remind myself. Okay, what's my period here? Is 2 pi divided by 2, which is pi. So it's going to look like this over here, pi units away. So 1 grid marking to the right of 0, to the right of pi, to the right of 2 pi. Okay, so those are going to be mins. It's going to have to go up, come back down to here. So halfway in between here will be 3 grid markings from that min. Is going to be a max up here. Halfway in between those is going to be on the midline. Halfway in between those is going to be on the midline. Okay, that's a cycle. Notice how it doesn't have a complete valley. It has a complete mountain, but really there's 2 parts to your valley. So from minimum to minimum is a cycle. It's just that normally we call it a valley and a mountain. Or I do, not everyone does. So then halfway here is going to be up top. Halfway will be on my midline. On my midline here. Okay. Then halfway here. Remember, you're basically dividing each period into 4 parts. Right? Each, no matter what kind, if you're talking about post that starts up and goes back down and starts up, etc., there are 4 parts. Right? 1, 2, 3, 4. Now, if you were to graph this to check, let's do that. So y, clear off, -3, post, the bracket opens, so it will be 2, open another bracket, x minus pi over 6, close 2 brackets, plus 1. Take your window. Here, it's going from what, negative, we'll just go -2 pi to +2 pi. And it's going by pi over 6, although that scale doesn't really matter. -4 to say +5 is what our graph paper is. Okay, looks kind of the same, but in a way a little bit hard to tell. I would actually, what's kind of nice, if you graph your midline, y equals 1. Okay, then if I find this point of intersection here, intersection, oops, no, that's not intersection. Okay, I want to go to that first positive point of intersection. Okay, take a look at it. It doesn't mean much to me, right? It's got decimals, so if I copy that out, and what I think it is 2, 4, 5 pi over 12. Okay, so if I figure out what 5 pi divided by 12 is, it should be the same. Okay, so if you look at what x value you think that is, you can compare it that way. Right? Pi, they're going to use decimal values, so it can't convert. If I try to take that and go math graph, it's not going to do it for me. Right? But if I put in what I think it is and compare the decimals, then I'm good. Okay? What might be easier is, this is a nicer, find your minimum point there. So if I go second trace minimum, or maximum, but if I do that 1, because that's the first point that I even got when I was graphing it. Okay, so y is -2, x is this decimal. Copy out the x. I think that that's pi over 6, based on my graph, and it is. Okay, so our graph is correct. Okay, so you can use your calculator to help you a little bit. It just takes longer.
Okay.
Yes.
Can you show us the equation that you put in the
So -3 post. Post opens a bracket, so all that's different is that there's 2 sets of brackets there.
Oh.
Okay, so for that same graph, or same function, the amplitude is 3, phase shift, so these are the easy questions, right? Phase shift is pi over 6, vertical displacement is 1, period is pi. So, general case, because we end up asking more general case questions, because you actually have to understand what they mean. So, guys, quiet please. So, there's your transformations. Amplitude is the absolute value of A. It's equal to the vertical stretch factor. If A is negative, there's also a reflection in the x-axis. Remember, we're not going to ever in this course make B negative. Okay, so it's always going to be a reflection in the x-axis. That's reflection. Sorry. Vertical displacement D is equal to the vertical translation. Okay, that vertical displacement amount is also called the median value. Okay, median value. Remember what median means. You guys did stats last year, right? It's the middle value. Well, it's the middle value between your maximum and your minimum. It's the median value. You might see the odd time ask for the midline value. Again, it's the same. If the value is just the number, it asks for the equation of the midline, or just what is the midline? It's a line, so you need an equation. Okay, so that would be y equals d. Phase shift C is equal to the horizontal translation. So determine the phase shift given a graph. Use a point on the basic graph that is not affected by the horizontal stretch. Because if there's a stretch, then you don't know where you're at. But remember, for sine, it's not really the initial value, but it goes through the origin. So the x-intercept and the y-intercept are both 0. Stretches don't affect them. So you can really tell what those translations are. For cos, the y-intercept is not affected by a stretch horizontally. Okay, so for these functions, that point is the y-intercept. Remember, for y equals cos theta, the y-intercept is one of the invariant points on the graph. For y equals sine theta, the y-intercept lies on the midline. Okay. And the slope of the graph at the y-intercept, so sine, remember, is going up like that. So we call that, remember, positive slope. So it's kind of a way of remembering. These aren't, these sort of, these things in here, these are just helpful properties to help you graph. I'm probably not going to ask you like any definitions like this. This you have to know. Phase shift is a horizontal translation. Amplitude is a vertical stretch factor. Displacement is a vertical translation.
Invariant points? Why? Can you just do the min or max value? Or, well,
Oh, here.
Min or max. What's it called? Invariant?
I don't know. Let's check it out. Y equals cos, the y-intercept. I was thinking it's invariant under a horizontal stretch.
Oh.
But that, yeah, maybe this is really talking about phase shift, so I was thinking, yeah, good point there. I would actually, yeah, let's change that to max or min points.
Alright, well, if it's just y is cos theta, then it's, oh.
You know what I mean? That's why it's a little bit. If it has been reflected, but that y-intercept is a maximum on the original. If you reflect it, it's a minimum. Yeah, so good point there, Jackson. Okay, then some information about the period and the B value. So period relates to the horizontal stretch. Okay, so your base graph, the period is 2 pi, or 360 if we're dealing with degrees. So if we're dealing with radians, and we've got a b value up here, we're multiplying it by 1 over b. Right, so that's the formula we've been using. Period equals 2 pi divided by b. If we rearrange that, then b equals 2 pi divided by the period. So sometimes we'll give you some information in words, and you have to come up with the equation. So if we tell you the period is 4 pi, you can come up with the b value, right? So 2 pi divided by 4 pi will be a half. If it's degrees, then obviously it's divided by, still same thing, divided by b, but it's 360 degrees. And what is a neat property then with sine functions? So let's say we had that sine graph. So the period there is pi, right? So what is our b value if the period is pi? 2, okay? This only goes to pi. If I extend this, actually let me just see if I can move this over. So if I extend this to go to 2 pi, let me just fix that a little bit. Okay, there's 2 pi there. How many cycles do I have in 2 pi? 2 cycles. Okay, that's going to be the same as your b value. So your b value, yes, it helps you get your period. It tells you, the reciprocal tells you the stretch. But looking at the graph, that b value tells you how many cycles you get in the original period of sine, or the original period of cos. Okay, so we have 2 cycles because you horizontally stretched it by a half. So you could find the b value if you're given a graph. Just count up how many cycles you get in 2 pi. That's your b. Right? You don't even have to do any formula with that. Okay, if you're given a graph. So that's going to be helpful in some cases as well. Okay, so let's do first part of question 4 and then we'll stop for today. Okay, so sinusoidal, it could be sine, it could be cos. Given a graph, you can come up with equations using either. We'll tell you usually which one we want. Okay? In this case, graph of either y equals cos or sine, but we're going to use sine for this one. Okay? So we've labeled it for you. There's your sine. And the solid one, the darker one, is the transformation. Use your transformation skills to determine the equation. Remember that, okay, so in this case, we're keeping A positive. And, of course, B is positive. Okay? So what I do here, I'm going to draw my midline. Actually, that red is faster. It's okay. Faster. Halfway between the max and the min, draw my midline. Okay? Distance from the midline up to the maximum, that's 2 units. Okay, so my amplitude is 2. Oh, sorry, 2. Not going to fill that in yet. It could be that it's 2, but from that midline it's going down and to the right. In that case, it would be negative. This is positive, and we also said A is going to be positive for these particular questions. So that's going to be the same. Okay. Period. So, take a look here. There's 0 to 2 pi. Based on what we just learned, I'm going to look. How many cycles? 1. Okay? 1 cycle. So the period is 2 pi. So B is just 1, which we don't even show, right? But if we have to state what B is, it's 1. Okay? Phase shift. Well, from that midline in the y-axis, it is going up and to the right, guys. So has it moved horizontally, left or right? No. So there's phase shift is 0, C is 0. You can say none here, and then C is 0. And then median value, well, I drew a midline that wasn't the x-axis, right? So there is a median value. It's at 1. And so B value is 1. Okay? So from there, we want to, oh yeah, let's cut off on mine. And then come up with the equation. So, y equals amplitude. We're dealing with sine. B value is 1, so we don't need to show it. We look at the horizontal axis. What variables use? It's x in this case. So x, if there was a c, I would put it in there, but there isn't. So I'll just close the bracket, plus 1. That's pretty easy. Not a whole lot to think of. Okay? So that's where we'll leave it for today. And then we're not far behind. We just have a few more to do, and then finish that off tomorrow. Okay? Okay, so the next one in question 4. Looking for the properties. I need quiet, please. Okay, so we've graphed, in this case, y equals cos theta for you. It's the lighter one, maybe dotted on yours. And then we want you to come up with the properties of the solid darker graph, and then come up with the equation. This tells you we want you to use cosine. Okay, so remember how my suggestion is to do the midline first. I'm just going to use the big solid red. Take a look. The max is 4, the min is -4. So nothing's changed there. It's the x-axis. I'm just using the big solid because it's fast on the smartboard. I don't have to change colors. Then from there, the amplitude is 4. Okay, so if I'm given the graph, I don't actually even use a formula, right? I look and find, basically you're finding the median of those two numbers. Okay, so it's the same as the average in this case because there's only 2 numbers. And then I don't use a formula for the amplitude because I can see it there, right? So the amplitude is 4. So given this, I think in the initial directions, we're assuming that the A value is positive. So that's going to keep that at 4. We're going to do some today where we give a negative. Okay? In this case, 4. Then, take a look. The theta axis is in degrees. Okay? So, we want to look for a complete cycle. And now my red line is maybe a little too thick right now. Let's move it down for a sec. So, you can start at the y-axis if it's a nice value. It's not great, but you can see the exact same value there and take a look. It's 360 degrees. Or you could look at the midline where it starts going up, a complete mountain and valley. That is, each 180 is divided into 4 parts, so each grid line is 45 degrees. So that's -45, and this is 45, there's one grid line to the left. So if you think about it, that is 360 degrees. So wherever you choose, just make sure you're choosing a complete cycle. It's 360 degrees, which is your base period, right? So the B value is 1. You wouldn't even need to show it in your equation. So now I put this back up here. Phase shift. So remember, your cosine starts at the top there, okay? So now, if I do the stretches and the vertical stuff, it would be here going down. On this transformed graph, it's over here. So what is that? That's 1 grid unit to the right. What did I say each grid unit was worth? 45. So the phase shift is 45 degrees. And so C is 45 because we're subtracting C there, right? So if the axis is in degrees, then you show that in degrees. Okay? That's the only part of that function that tells you what measure the angle is in, is that C value. Otherwise, it can be either measure. Median value, well, it's the x-axis, so it's 0, right? So D value is 0, so we don't even have to show it. So when we come up with our equation, amplitude, we're doing cos. B value is 1, we don't need to show it. There is a C value, so I'll open brackets. This, they're using theta, so theta minus 45 degrees. And then we have 0 for D, so we don't show anything. And you're done. Yep.
So I'm still a bit confused on how to find the phase shift value. You just pick a point that isn't affected by the horizontal stretches. So the
yep.
y-axis. Oh, and then you. Oh, okay.
So basically, here's your base graph.
Right.
So we're dealing with cosine. So choose the y-intercept, whether it's cos or sine. Cos is here. Think about the stretches that have been done. So obviously the amplitude is the stretch here. So 4. And we're not reflecting it. Remember we said A was going to be positive. So 4, that means it would be going down and to the right. Okay? So I do a little arrow like that, and then I look at where do I have to move that? I have to go to the right, 1 grid unit. How much is a grid unit?
Okay, got it. Thank you.
Okay.
Yeah, that's wrong.
Yeah, that's wrong. Right. There are some errors in Sinusoidal. Yeah. I'm going to blame Miss Dessens again. She's retired. I don't know. That was the last 2 years. She's tired. There's a couple. There's another one coming up. There's an error too. I didn't see that one. But. Okay. Next one. Now we're back to doing sine. Okay, so there's your base graph is the dotted. Here's your transformed graph. So I'm going to do it just freehand here. My midline is the x-axis, so it hasn't changed at all. Okay, so my amplitude is 1. It hasn't changed at all, right? But the period, so now, again, up to you. Take a look at what's nice is you can find the point on the y-axis. That's when the x value or theta value is 0, and find where it repeats. So that's at a minimum. If I go up and back down, I'm at a minimum again. So that's 1 complete cycle. Then take a look. Okay, so that is 4 grid markings out of 6 in 180. So each grid marking here is 30 degrees. You might want to do that right away. Figure out what the first grid marking is worth, because that's what all of them will be worth, right? Each along there. So now that's 30, 60, 90, 120. Okay? That's a complete cycle. So the period is 120. Remember, B, if we're dealing in degrees, is 360 divided by the period. So the B, folks, quiet please. Okay, take a look at what we learned yesterday. In the regular period, for sine or cosine is 360 degrees. Rahul, are you listening? So in the regular period, how many cycles do we have? We have 1, 2, 3. That confirms that he is through. Okay. Phase shift. So if I did take a look at my original graph from the midline and the y-axis is going up and to the right. Okay. There is no vertical stretch. There is no d value. The d value is 0, right? So we're really comparing it right away to where is the new graph going up and to the right closest to it. So this is the closest that's going up and to the right. Obviously it goes over here. We could go over to this one. We're always going to want the shortest translation, the closest. So what is that? That's 1 grid unit, which is 30 degrees. So 30 degrees to the right, so C is 30 degrees. Okay. So our equation is y equals, we don't need to show the 1, sine, I open the brackets, put the 3, open another set of brackets. We're dealing with x now, minus 30 degrees, and that no d value. Okay. You could also, obviously, it didn't, oh, actually it did specify. Can I erase that? It gives it to you in this form, so we want it in that factored form. Just look at the graph. Yeah. Yep. Probably not the first time, but if you keep doing it, yeah. So we'll be kind on the first curve. Try to look back. Like obviously, that's not you're not going to lose a lot, but
like a half mark.
Yeah.
Well, that's why you don't do quarter marks.
It'll be like maybe a half over the whole test or something if you do it more than once, kind of thing. That's that attention to detail we talked about. Okay, so this one, take a look. So the original graph is a post graph. It's graph for you. There's your new graph. So it's obviously translated downwards. So again, I'm not going to use my thick one just because it's going to take up. So I'm freehanding. It doesn't have to be perfect. Remember, this is just helping you. Then to a maximum, that gets me my amplitude. Take a look. It's 1 grid unit, but each grid unit vertically is half. So this amplitude is a half. And again, use fractions rather than decimals, unless it's an application question that has decimals in it, right? Okay. So my amplitude is a half. So A is a half. My midline is, or median value is -2. So my D value is -2. Those are the easy ones to get right away. Then take a look. I don't have a complete cycle graph there. So if I go from here to here, how much of a cycle from that dot, red dot to red dot? Half a cycle. I'm going from a max to a min. So that's half a cycle. I mean, I'm getting close, right? But if you go across, it wouldn't be the same. So if you can find, guys, the length of half a cycle, then just double it to get the period. So here, this length, so that's starting at 0 to 3 pi. So this is 3 pi. So our period is going to be 6 pi. Okay. This is half a period, half a cycle. Okay. So our B value is 2. So remember, B is 2 pi divided by the period. And your B is 1/3. Okay. So think about it in 2 pi, you can tell you're getting a fraction of a cycle in the original period. You're getting 1/3. Okay. Then phase shift, is there one? Not if we're dealing with coasts, which we are, right? There isn't one. It's starting at a max at the y-axis, as the original does as well. So nothing there, right? So here, y equals 1/2 coasts. So if there's no phase shift, I'm just going to go 1/3 theta, or theta over 3. Right? Same thing. And then minus 2 outside of that. Okay. Just be aware that sometimes when questions are typed up, you might see, like for example in this, you might see that, and that would still mean 1/3 theta, okay, in most cases, unless there's maybe some space or dot or something, like we wouldn't multiply cos of 1/3 by an angle. Like the context of it doesn't make sense. So sometimes it's just the computer program. Could, but what? Yeah, in our context, we're not. In our grade.
What on the somebody after doing it in terms of that of 1/3 minus 2? They can't. Then actually 1/3.
That they would have to have brackets. So if it was like this, okay, that for sure is not 1/3 theta minus 2 in brackets. Okay, if you're subtracting in there, you have to have brackets. Yeah?
What if you didn't include 1/3 in the bracket, but it's still in between theta and cos?
That's what I was just saying.
That's fine.
So that would be, we assume that would be the same as with brackets.
It's just like
Because you're not gonna, like, when are you gonna multiply cos of a number by an angle? It's very not in our curriculum. Maybe. Okay.
Like the thing where you write, like for example, like y whatever, and then have cos 1/3 and then the brackets. That's stylistic.
Yeah, that's as well. Still an argument. Okay, question 5. So the graph of y equals sine theta is vertically stretched by a factor of 3, horizontally stretched by a factor of 2, reflected, translated. It says determine those particular properties and then write the equation. Okay. So I would actually probably write the equation first myself. So think about it. If you start with y equals sine theta and you vertically stretch by a factor of 3, and then horizontally stretch by a factor of 2, you would get that. So that's doing your stretches. Okay. Then reflect in the x-axis would be -3. And then left and up. So now I would change that to square personally. But if you got rid of that bracket and just put it around the theta, that would be okay. And that would be theta left would be plus pi over 8. And then up. Okay. So amplitude is the absolute value of A, so that's 3. Vertical displacement is same as the D value. Phase shift, here we went left pi over 8, so it would be negative pi over 8. Right, you're going left. Rahul, you're chatty today. Well, a lot of days, but today seems more. So, and vertical. Oh no, we did displacement. Period. Period is 2 pi. So I'm going to use radians because that phase shift, the horizontal translation was in radians. There was no degree symbol. So 2 pi divided by a half is 4 pi. Okay, and we already have
Would you like to do something just to see the way that we go pi over 8 degrees?
You never know.
That'd be so mean, yeah. Everyone would get it wrong.
Attention to detail. Explain that. You ready to throw some dice there? Yahtzee?
One die?
That's probability. Okay, so that's question 5. We're going to go on to the next. I'm just going to pause my video because we split it up.